This is the next video in the chapter on stoichiometry of chemical reactions. We just practiced using stoichiometry with chemical situations, with chemical reactions, to predict the quantity of product that would be produced. But now we need to come to the understanding that in real life, nothing ever goes as planned, and we need to adjust for that. So in the problems we just talked about, we used up all of the reactant that we were given when we predicted how much product was made. But in real life, especially in science, we never have exactly the right amount for everything. When it comes down to the atomic level, it is almost impossible to measure the correct number of atoms of anything. So we never have the right amount of all the components. We usually have extra of at least one. And you've experienced this yourself too. Have you ever pondered in the shower why hot dogs are sold in packs of 10 and buns are sold in packs of 8? We may never know, but at least we can learn the appropriate terminology to describe that sort of a situation. So hot dogs are not my favorite thing. I'm more of a fan of grilled cheese. So we are going to do a grilled cheese example. Yes, it is another example about food. But if you can understand a concept using food, then you will be prepared to understand that concept using chemistry. So if I was really cheap because I'm a poor college student and I wanted to make grilled cheese sandwiches to eat for every meal for the rest of my days, my recipe for grilled cheese sandwich would be 2 slices of bread, 1 slice of cheese, and 1 sandwich. And so these are pretty easy, straightforward ratios. So you can probably predict how many sandwiches you can make from the ingredients you have in your fridge pretty easily. So for example, how many sandwiches could you make if the fridge has 10 slices of bread and 5 slices of cheese? You probably don't need any dimensional analysis to figure this one out. You can probably do it in your head. You can make 5 sandwiches. Great, ideal, perfect. But what if life wasn't quite so perfect? What if you only had 4 slices of cheese because one of them got eaten for a snack yesterday and your 10 slices of bread that came in the pack? How many sandwiches could you make with those ingredients? So it depends which ingredient you look at, right? If we just look at the bread, we have enough bread to make 5 sandwiches, right? 2 pieces of bread for sandwich, 10 pieces of bread makes 5 sandwiches. What if we look at the cheese? We only have 4 pieces of cheese, and we need 1 piece of cheese per sandwich. So we only have enough cheese to make 4 sandwiches. So I've ran out of cheese. I don't have enough for that 5th sandwich. So in this case, I can only make 4. Or in the case of the hot dogs and the buns, I would run out of buns before I ran out of hot dogs. So we have ways of describing these different elements, the one that runs out first and the one that doesn't run out first. So we say that the amount of bread given in this problem is in excess. So we call this the excess reagent because we have more bread than we need. And usually we write this as a capital EX for shorthand. And so you can tell if something is an excess reagent because it makes the most amount of the product. And you can have multiple excess reagents depending on how many reactants you have in your problem. If you had bread, cheese, pickles, and lots of other ingredients on your sandwich, you would have multiple excess reagents. So the excess reagent makes the most amount of product, so 5 greater than 4, bread is our excess reagent. Our cheese limited the number of sandwich we could make. We wanted to make 5, but we were limited by the amount of cheese and we could only make 4. So we call the cheese our limiting reagents. Or sometimes it's called limiting reactants in some textbooks. And we abbreviate this one as a capital LR. You can identify that something is the limiting reagent because it makes the least amount of product, of the same product specifically. There we go. So the cheese made the least number of sandwiches, so that meant the cheese was the limiting reagent. There can only be one limiting reagent, but you can have many excess reagents. And so this is going to be a useful skill when we start to increase the number of reactants to numbers that are a little bit more uncomfortable to do in our head. So if we have 322 slices of bread and 275 slices of cheese, because maybe this is the Andrew Commons dining hall, making sandwiches for all the Lawrence students, then we're going to need to use dimensional analysis and the concept of limiting and excess reagents to figure out how many sandwiches we could make. So we need to figure out which one of our ingredients, bread or cheese, is limiting in this case by predicting how much product we could make from each of them. So let's predict how much product we could make if we used up all of the pieces of bread. So if we want to convert from bread to sandwiches, we're going to use a stoichiometric ratio. So our ratio is going to be 1 sandwich to 2 slices of bread. Okay, so bread cancels, sandwiches left. We can make a maximum of 161 sandwiches if we use up every piece of bread that we've got. So then we're going to look at how many sandwiches we could make if we used up all of our cheese. So 275 cheese slices. We're converting between one compound and another, so we need a stoichiometric ratio from our balanced reaction, 1 sandwich to 1 slice of cheese. And I would encourage you to write it all the way out, even though all you're doing is multiplying by 1. It's a very significant multiplication by 1. We completely changed what compound we were talking about. We determined we could make 275 sandwiches if we used up all of the cheese. So now we can see that 161 sandwiches is the smaller number. So we're only going to be able to make 161 sandwiches because we are limited by the amount of bread that we have. So bread is going to be our limiting reagent because it can make the fewest number of sandwiches, and cheese is going to be our excess reagent because it can make more sandwiches than a limiting reagent can. Because 275 is greater than 161. So it's important to be able to predict how much product you can make, to identify which reactant is limiting and which ones are in excess. And it's also important to say, if cheese is in excess, how much of it is going to be left? If I'm not able to use it all, how much am I going to have left over for tomorrow? And so we can figure out how much is left over by determining how much we've actually used up. So we would have liked to make 275 sandwiches, but we only made 161. So some cheese is left. So we made 161 sandwiches. And I want to figure out how many pieces of cheese I used to make those sandwiches, so I can sort of do the reverse of what we've just done here, use this ratio and flip it to solve for cheese instead. So we'll put 1 cheese over 1 sandwich. So that tells me 161 pieces of cheese. And now we need to stop and make sure that we think about when we use this cheese. So this is not the cheese that is left over. This is the cheese that was used up. When I made 161 sandwiches, I used 161 pieces to do that. And now we can use that to find the remainder. So I had 275 pieces of cheese available in my very large fridge. I used up 161 to make the sandwiches, so we'll subtract that, and that gives us 114 pieces of cheese left over, or remainder. So there's sort of 4 sorts of questions here that you should be able to answer, and those questions are, how much of a product is produced? Which reactant is the limiting reactant, and which reactants are in excess, and how much excess reactant is left over in a particular situation. There is math involved here, but as long as you get the ratios correctly set up, all it is multiplying and dividing. All math skills we are all completely capable of doing. So in the next video, we will talk about what happens when not everything goes to plan and some of your product gets lost.